Should be live. Record. There you go, Chad. Okay. Okay, apparently I'm live. Very cool. Getting a warning that the bit rate is a little lower than it should be. I'm doing 4K, 60 frames a second. So let me know if you're seeing any problems. It's never enough. Okay. Mark Olwick, why does Artemis need solar panels when Apollo never did? Right, so if you watch the Artemis mission, one of the cool moments was when the Orion capsule extended its solar wings. And these are designed to provide a tremendous amount of power to the spacecraft as it was doing its mission around the moon for Artemis 2. And the solar panels on Artemis 2 deliver 11 kilowatts of energy to the spacecraft. And that's enough to supply all of the machinery equipment on board, to be able to run the electronics, communication systems, and so on. Back in the Apollo era, they didn't have solar panels that were anywhere near as good as what they had during the Artemis mission. Like, I think solar panels had just barely been developed at that point. And really, you didn't get to see proper solar panels, people putting them on their houses and stuff until the late 70s. And so they had to use a completely different technology, which was using an energy cell. They used a hydrogen-oxygen fuel cell, and there was 3 of them on board the Apollo command module capsule. And then they had batteries that they used for the lunar module. And so each of the fuel cells would deliver 1.4 kilowatts of energy to the capsule for the duration of the mission. And so you add 1.4 times 3, what's that? 3, like 4.5, just shy of 4.5 kilowatts, total kilowatts of energy, compared to what they've got with the Orion capsule with the Artemis 2, much, much more energy. And so the reason that they had to do it is because they didn't have any other option. If they could have done solar panels, they totally would have, because solar panels just run forever and provide you an enormous amount of electricity for the weight that you have to extend for them. I mean, solar panels at this point are paper thin. Like, they are often not much thicker than foil. And yet they're able to provide energy. And the ones that NASA uses are extremely high efficiency. And so now all spacecraft run with solar panels and these high efficiency solar panels. In fact, NASA developed the high efficiency solar panels to make their missions work for longer duration. Of course, solar panels are what powers the International Space Station. I mean, when you look at the space station, you see the big solar power wings. And something like this is going to be required when there's a permanently inhabited base on the moon. The challenge with having some kind of base on the moon is that, of course, you have the lunar night. So you have a 14 lunar day, and then you have the 14-day lunar night. And in the lunar night, you don't get any solar power, and so you've got to come up with another way. And the plan for that is to use a fission reactor. NASA is working on something called the kilopower reactor, so kilo 100. So the goal is that you'll have this fission reactor that can be on the moon, supply 100 kilowatts of power for the duration of the, for as long as the fission reactor can last. We know these things can last for years, and that'll be able to keep the astronauts warm and give them enough electricity during the lunar night. So yeah, just so much better technology now. Not just, I mean, the solar wings are one part of it, but when you think about all of the other small changes that are there, I mean, there's just so much new technology in Artemis compared to what was back in the Apollo. What's incredible is how they got it done. I mean, the computer on Apollo is ridiculously simple compared to the kind of technology that we have available today. And yet they took people to the moon, down to the surface, and back home safely. Incredible. Where am I? Okay. Hey, everybody. How's it going? I've been having a good time. The weather's gotten really good, and so I've been out all day over the weekend, clearing brush, cutting down trees, working in the garden. It's been great. Man, I missed nice weather, and we finally got it. Of course, the way it works here on the west coast of Canada is we get terrible weather, storms, snow, rain, wind, and then late April, May, the weather changes, and then we don't see rain all the way through till September. It's very kind of Mediterranean at that point, and we're dying for rain by September, October. But we hopefully we'll get a few more rains. We have this, so sometimes June can be very wet, so we call it January, but I think this is going to be a very hot, very dry summer. That's what everyone is saying. There's an El Nino year, and so my sort of terror is fires, forest fires. And, we saw a lot of burning over the last couple of years in Canada, and I'm going to be out there removing the fuel from the forest floor, cutting down trees, giving a bigger separation, removing the lower limbs so that fire can't go up, making sure there's not any sources of fire near my house. It's a lot of work. And, partly I'm driven by fear of fires, and partly just because I really enjoy being out in it. We get so much wildlife has returned. We've got, I could rattle off a bunch of birds that are native to our part, or I guess they can have a wider range. Like I'm sure many of you are familiar with white crowned sparrows, golden crowned sparrows, juncos, towhees. We've got 6 squirrels that are rampaging around in our garden. It's great. It's great. What else have we seen recently? Deer. Haven't seen my first bear this season yet, but it's about time for the bears to come out. And so I should see a bear very soon. We've got a couple of ducks that are swimming in one of our ponds. And it was amazing. Yesterday, the ducks came up into our garden, and my wife and I were just sitting on a couch right in front of the garden, and the ducks just kept getting closer and closer and closer, and they were probably maybe, I don't know, 5 meters away from us. It was amazing. Mallards. So yeah, it's we've switched into the full-on paradise portion of the year, and I am so excited for it to be back. Next comes swimming in the river and the lake. All right, so let's get into this week's question show. Your questions, my answers, all that. A few ground rules. I try to give emphasis to the people who've never had a question answered before. So come on, be brave. Ask your question. I am a journalist, not a scientist. So, I cannot provide you original opinions about space and astronomy topics. I can merely convey the scientific consensus. And then the last thing is, I try to run a sort of running simulation in my mind of all of the episodes that we've done and the questions that we've had a lot of. And so if I don't answer your question, could be because I don't know the answer, could be because your answers could require a lot of math that I just don't want to do right now, or it could be that we've answered that question a lot. But once you've asked your question once in the YouTube comments, and then it goes into a database, and I will be able to look at it over and over and over again and go, do I want to answer it now? Do I want to answer it now? But typically I get through about a third or even a half of the questions. So typically we get through about 40 to 60 questions during this 2-hour episode. Oh, did I mention that this was 2 hours long? Yeah, you're locked in. And of course, we are now keeping all of these episodes live permanently on our YouTube channel. And so for those of you who want to just have me rambling in the background while you're working on some project, maybe you also are in the forest desperately trying to decrease the fire load risk on your property, then I'm here in your ears while we do this work together. All right, let's get into the questions. Geohondo, is it problematic to keep rocket fuel in space for extended time? I hear hydrogen escapes no matter what, but I don't know if that's true. Yeah, this is one of the biggest problems with space refueling. So this idea of space refueling, like up until this point, rockets have to carry all of the fuel on board for their entire mission. And when you think about something like, say, New Horizons that launched from the Earth, flew past Jupiter, did a flyby of Pluto, flew past Arikoth, another Kuiper Belt object, and still has a little bit of fuel in the tank to probably see another target, it had to carry all of that fuel in all of its stages. And it doesn't even have an ion engine. It just had to be able to use a normal propulsion system to be able to... It had to use a regular old chemical propulsion system to make that journey. And that everything else, right, is just... You put the fuel on the rocket, you launch it into space, it completes its mission. And even when you go back to the Apollo missions, right, you had Saturn V, all of the 3 propulsion stages. You had the command module, the landing module, all of the fuel. Each one of these little modules had its own little fuel tank and its own little rocket to be able to allow it to complete its mission. And one of the big ideas that several of the aerospace companies have been suggesting, and the big company for this actually has been Lockheed Martin. Back in the late 90s, early 2000s, they were starting to pitch this idea of fuel depots in space. And the idea is really elegant, right? That if you are able to launch your spacecraft into space, it doesn't have to be that big if you aren't going to be carrying very much of your fuel. And then, and if you're going to be carrying people, it can be a very safe rocket, something that's designed 100% to just carry humans to space safely. And then you can refuel at one of these fuel depots. Now, today, you're going to have to launch rockets that will refuel the fuel depot, which will be a different thing. But they can be sort of more cargo spacecraft. They don't have to be as safe as the ones that are for carrying people. And then your human mission to the moon or to Mars or whatever goes into space, goes to this fuel depot, replenishes its fuel, and then it can carry on its entire mission. And you've got all of that capacity for fuel, the fuel capacity that you use to just get into orbit. You can now fill it all back up again and pretty much go anywhere in the solar system with that fuel. And then, of course, the other mission that you've probably heard a lot about is the SpaceX Starship, the human landing system, but just like in general, SpaceX has been thinking about how you can do orbital refueling. And a lot of their long-term ideas really depend on orbital refueling. If you want to send humans to Mars, you launch this thing, it uses up all its fuel to get into orbit and then meets with the fuel depot, replenishes its fuel, or you have other starships filled with fuel that meet up with it, replenish its fuel, you fill its fuel tanks, and now you've got a spaceship that is completely filled with fuel, and you can easily make your journey to Mars. So the idea is very elegant. And in the far future, once we have, say, mining water off of the surface of the moon, or once we have asteroid mining, then the fuel depot makes a ton of sense, because then you're not having to bring up that fuel from the surface of the Earth. You're bringing that fuel from some other location out in space, where you haven't had to get out of Earth's awful gravity well. The idea makes a ton of sense, and it is absolutely, inevitably our future. But the challenge is that cryogenic propellant systems like liquid hydrogen, liquid oxygen, or even liquid methane, these are tricksy and can escape. And that there's a lot of other technical challenges you have to deal with when you're in weightlessness, the fuel is floating around inside your tank. And so you have to use pressure to be able to kind of push the fuel in a certain direction. There's various solutions to be able to solve this problem. But as you said in your question, it's hydrogen that is the worst. And that is probably the most useful propellant component, that you're going to mine water, you're going to break it into hydrogen and oxygen, you're going to store the hydrogen in liquid form, so under a compressed liquid form in your fuel depot. But hydrogen, the atoms of hydrogen are so small, the molecules, if it's H2, but hydrogen is so small that it's able to get out of almost every kind of containment. And when you're out in space, your fuel depot is going to be going through cycles where it's going to be getting heated and cooled if it's in orbit around the Earth, and it's going to the shadow of the Earth. And so all of the metal is going to be expanding and contracting, and you've got to be able to come up with a fuel storage system that can handle that. So people are working on solutions both for the storage of cryogenic fuel as well as transferring cryogenic fuel. There have been test experiments installed on the International Space Station. The Chinese just recently, within the last couple of months, tested out a refueling spacecraft that would try to deliver fuel. In this case, it just delivered fuel to itself, but it, in the future, you'll see that. We have seen servicing spacecraft that have been launched and have docked with target spacecraft. But right now, the only really official plan is what SpaceX is going to be doing, and not even a fuel depot. So they're going to be launching the human landing system into orbit, and then they're going to launch other starships that are going to have to dock with the human landing system and transfer propellant to it, and then it's going to travel out to the moon and bring the astronauts to and from the surface of the moon. So this is the dream for long-term reusability, space exploration, but there are a lot of technical challenges. And I always sort of use this as one example of why space exploration is going to be so hard, and that there are all these little tricky things that we have to work out. How do the astronauts eat? How do they drink? How do they breathe? How do they go to the bathroom? What do we do? What do we do with waste? How do we deal with the medical issues? Long-term space exploration is going to be very challenging. And yet, if we can overcome this, it'll bring out the best of us. So let's do it. Ed Skeptic. Biosphere 2 didn't work on our... Ed Skeptic. Biosphere 2 didn't work on our hospitable planet, so how are they really going to do it on the utterly inhospitable moon or Mars? Yeah, for those of you who haven't heard about it, Biosphere 2 was this experiment done in the Arizona desert, just outside Tucson. And I've visited it, and it's amazing, where they were trying to create this fully enclosed habitat that was self-sufficient. So they had a bunch of people who went into this thing, they sealed it up, and they had enough plants inside of it that they would recycle their air. They were growing their own food, recycling their water. They had animals, and they were trying to see how long they could run this experiment before it went off the rails. And it turns out that they hadn't fully cured the concrete, and so it was extracting oxygen out of their environment, and they were getting less and less oxygen, more carbon dioxide was building up, and in the end they had to let in some oxygen to replenish the environment. And they weren't very forthcoming about what they were doing. There's some great documentaries about this. I highly recommend it, and if you can get a chance to go and see Biosphere 2, it is really inspiring. And that is not the only attempt that has been done. So the Chinese have a version of this they call the Moon Garden. And it's the same thing where they have enclosed it, and, not as complicated and architecturally satisfying as the Biosphere 2 is. But they were able to go about a year and have it be fully, self-cycling. So we know in broad strokes how to do this, but I am just shocked that there aren't continuous Biosphere 2 level experiments going all the time. That there should be a Biosphere 2, or whatever is the version of it, right? Biosphere 2, because there's the regular Biosphere, the Earth, and then Biosphere 2 is the, us creating a secondary Biosphere. So we need something like that. And I don't think Biosphere 2 is the right facility for it. It was kind of overbuilt for what it was. And maybe it's the Chinese version with the Moon Garden. That's going to be the way to go. But you need some place here on Earth where people are trying and testing out, can we do long-term cycling of our environment and keep everybody alive. And you're absolutely right that we need that for a moon base or a Mars base. But we can still add inputs. So with the Biosphere 2, one of the things they said was, well, we're not going to add any inputs. We're not going to add any food. We're not going to give them anything. They're going to try to live off just essentially the sunlight that is coming through the Biosphere glass. That is going to keep them alive. And we can supply food, water, additional stuff to a lunar base or to a Mars base. The trick is that that'll be the limitation, that if we can't keep up with their needs for the food, for the resupply, for medical equipment, for whatever, then they will starve and die. So we've got to be able to have them be as independent as possible, and then we can replenish them from there. And the moon is the perfect place to do this. The moon is very close. The moon receives the same amount of sunlight as the Earth does, although it's broken up into 14-day-long days. 14 days of day, 14 days of night. So that will be a challenge that will need to be overcome. But if they run out of something, they run out of toilet paper, you can send more toilet paper in 3 days on the next resupply mission. And I think that we won't even imagine having a long-term presence on Mars until we have demonstrated for a decade, right? 20 years maybe of long-term presence on the moon, that we have just dialed in all of the engineering challenges that it's going to take. Now, you can send people to Mars earlier than that, but you might be sending them to their death. So you just have to be aware that that is one of the concerns. So, I think, we need to prove that we can understand all of the factors, all the variables to running a fully enclosed ecosystem. And it gets complicated, right? What about medicine, right? Can we grow various medicinal plants that can be, or can we create biolabs that will be able to 3D print the kinds of things that we need? When you sort of think about all the things that you need every day, there's this short tail. You need to breathe, you need water, you need food, but then there's this longer tail. You need certain vitamins and minerals in your, in your diet. You need, replacement parts for various pieces of equipment. It goes on and on and on. You need various kinds of medicine. And when you think about all of the prescription medicine that, I'm sure if all of us watching, all of you watching this episode right now wrote down all the prescription medicines that you are on, we would have a list that could probably was hundreds long, right? And that's just like regular human beings, taking prescription medicine. And so how do we supply all of that over the long term? So these are all of the challenges. These are the engineering, the nitty gritty detail that we need to be able to figure out. And we have scarcely begun. That when you think about what happens with the International Space Station, we resupply, we pretty much deliver them everything they need. All of their food, all of their water. Yeah, they do have some reclamation of water. They grow a couple of plants on the station, but really all their food, all their water, everything is being supplied, all of their atmosphere, everything. So we need to be able to get better at that, and we're just not. Melvin Davis, I'm guessing from your description of your paradise that you have Bortle 2 to 3 viewing imaging condition. Can you please confirm? I think I have Bortle 3. So I am about 10 kilometers away from a city of about 50,000 people. And I can definitely see the glow of the city off to the horizon when it's dark out. And the best viewing that I get is when there's fog or low clouds over the city that blocks the lights from getting up into the sky. And then the sky just looks amazing. That gives me a hint of what my sky could look like if everybody in the city would just shut off their lights or turn them down. So I do have some light pollution. I can definitely see the Milky Way. It's great. It's definitely much better than, I can't imagine Bortle 8 skies. I can't imagine, I know for a lot of people, they live in Europe and their skies are just light polluted like crazy, and there's nowhere you can go. At least, if you live in Sydney, you can drive for an hour and be in much darker skies. But there's lots of places in Europe, but there's no place you can go, which sucks. The US, you've got lots of places you can go. Even if you're on the East Coast, there are dark sky parks. But there's a great website that I like. It's called the Dark Sky Finder, where it's like a Google Maps style interface, so you can sort of move around, zoom in and zoom out, but then they overlay it to light pollution maps, and you can find out not just what your viewing conditions are, but you can find the nearest dark skies to you. And like I said, like mine, let me see what mine is. Dark Sight Finder, sorry. I would say Dark Sky Finder, but it's the Dark Sight. So I live in green? Blue. Yeah, I live in blue in the Dark Sight Finder. And so what is that? So it doesn't show what the border is. But I would say if you can get to blue or even a green, it should be fine. Yeah, there's 15 colors on the map, so it doesn't map. Yeah. The Light Runner. If we lived on a binary planet system and built a large space station at the barycenter, would it be 0G in the middle of it? Yeah. So I'll give you sort of an analogy, which is imagine going inside the Earth. So if you went down to the middle of the Earth, you would be weightless, because you would be pulled at equally in all directions from the mass of the Earth. You would be floating around. In fact, if we dug a hole through the Earth all the way through out to the other side, and you jumped into the hole, and there was like no friction and there was no air, and you fell down, you would experience, you would accelerate as you are going towards the center of the Earth. And then you would experience this weightlessness as you got closer and closer to the center of the Earth. And then your momentum would carry you all the way up the other side to, your eyes would peek out of the other end of the hole, and then you would fall back down and just oscillate back and forth. And so if you had a binary planet system, an ideal binary planet system, which is impossible, which we'll get into in a second, you had two planets that were orbiting around each other, then if you were positioned right in the middle of those two planets orbiting around each other, then you would be at the barycenter of these two. You'd be at the barycenter of these two planets that are orbiting around each other, and you would experience weightlessness. And the space station would require the minimum amount of fuel to be able to maintain that position. And you sort of imagine it it's like a Lagrange point, that you are at the top of this gravitationally unstable point. It requires very little fuel to remain at the top of that point. But once you start to drift away, then you can imagine you start to drift closer to one of the planets or the other. You start to accelerate towards that planet, and then things go haywire. But that is the sort of idealized platonic version of that. But the reality, of course, is that the planets aren't going to be the same mass. You're going to have the influence of the star, the influence of other planets, that you are going to be perturbed just by all of these gravitational interactions. And it doesn't take much for oscillations to set in and for you to start to end up in a sort of chaotic orbit between the barycenter of these two objects, and you will eventually crash into one or be kicked out of orbit or whatever. And it's that same thought process you should use to imagine the unstable Lagrange points. When you think about L1, 2, and 3, which are lined up between the star and the planet, that those 3 points are gravitationally unstable. You can hover in that region with a minimum amount of fuel, but once you start to drift away from that idealized position, then you will sort of fall out of that gravitational well. And there's no perfect place you can be, because there's always the interaction between the other bodies in the solar system. I just turned that into a Lagrange question. Paige Potter. If we detected a technosignature tomorrow, what's the first thing scientists would argue about it? Well, everything. Right? That detecting a technosignature is probably the most profound discovery that humanity has ever made. You are not alone in the cosmos, and that there is actually some other intelligent civilization that is out there, and they are maybe aware of our presence and are communicating in our general direction. That is a lot for us to take on. And any scientist, their first response to that will be skepticism. Are you sure? Is this real? Did you really detect this technosignature? And especially if it's something that is right at the very edge, the limits of our capability. If we detect the presence of chlorofluorocarbon in the atmosphere of some other world, then with James Webb at the very limits of its detection capability, then scientists are going to go, well, these are the other chemicals that have similar spectral lines, and you could probably say that it was one of those, or maybe that there's noise in the equipment itself. But if we detect something that is unambiguous, I think about, say, Contact, right? The movie Contact, where you had this signal that is being sent from some other civilization, and that they've put binary code into the signal, and it's obvious that this is sent by some other intelligent civilization. Then I think you will still see people who are skeptical, right? Is this some kind of hoax? Is this some kind of scam? That it's going to take a lot of scientific inquiry to get to the point that people can be very confident. But then I think the most important question that you have to ask is, should you reply? Should you let this civilization know that you are out there? And this has shades of this idea of the dark forest, that, that the universe, when you think about the universe in terms of game theory, and you detect the presence of another civilization, they could be a threat to you. And so the best thing you should do is strike first, strike hard, no mercy. It's a ridiculous thought experiment, and there's all kinds of challenges and problems with the dark forest. David Kipping did a great response to this in Cool Worlds, and I largely agree with him that that there are other responses than we should take out that other civilization. But should we reply? Should we make them aware of us, or is this a scam? And then I think, if it is a message, something that, like when I think about the movie Contact, and it was the instructions for building a machine, and they would just went ahead and built the machine. That sounds like a terrible idea. Do not build the machine, because if you want to take out another civilization, send them instructions on a doomsday machine that'll wipe them out. That is so easy, right? All you have to do is just send them a bad idea. You don't have to fire your mega laser across light years of space. You don't have to send an armada to invade them. You just say, hey, build this thing. It'll be great. And then they build the thing, and it turns out to not be great. It turns out to, produce a black hole and destroy your planet or whatever. So I would say that's where the point of where the scientists would be arguing is, should we reply? And then should we trust anything that is in the message that they are sending us? And you may get to this place where you can't be safe. You can't know. Now people will just YOLO and want to try it anyway. And other people will be like, we shouldn't do it. And that's where I think the sticking point will be. It's a really interesting kind of philosophical thought experiment. And maybe people can recommend some science fiction that handles it really well, because the science fiction, I don't think the Dark Forest handles it great, and Contact definitely doesn't handle it great. Doesn't handle it well, but but I would be interested to sort of hear people's thoughts on who handles this in a very good and nuanced way. Okay. Terry Hardaway, would there be a circumstellar habitable zone? Terry Hardaway, would there be a circumstellar habitable zone for Earth-sized moons around rogue brown dwarfs? Yes. So, like, let's think about what you're dealing with here. So the habitable zone is this region around a star where liquid water can be present. And that region is, on the inner side of this, water boils. Venus is right at the edge of the habitable zone. And then on the outer edge, liquid water can just not be present, that you will always get frozen water. And Mars is just on the inside of the outside of the habitable zone. It's kind of amazing when you think about it that we have 3 planets that are located within the habitable zone of the solar system. Venus, Earth, and Mars are all potentially habitable if you tweak their atmospheres in different ways. So, but you could have a brown dwarf giving off infrared radiation. It's going to be, hundreds of degrees on its surface, tens of degrees on its surface. It is going to be giving off heat. And then you could have a moon that is in orbit around that brown dwarf, and it's going to be experiencing some level of heat coming from it. But I don't think that's the one that's going to be doing the heavy lifting. I think where you're going to get probably a more productive contribution of heat is going to come from the tidal interactions between other moons in the brown dwarf system and the main brown dwarf. So think about Jupiter, right? Jupiter with Io and Europa and Ganymede and so on. Io is very close to Jupiter. It has lava on its surface. Europa comes next, and it has oceans of liquid water underneath a thick ice shell. Ganymede does too. Callisto almost certainly does as well. And so that is the kind of environment that's going to give you the heat. But I think what you're really hoping for is, could you get liquid water on the surface of this moon around this brown dwarf? And it really just depends on how much heat the brown dwarf is putting out and how close the moon is to the surface of the brown dwarf. It might have to be really close, but you can get very close and not be within the Roche limit of your brown dwarf. And so there's going to be a habitable zone. There will be a habitable zone around any kind of star. As long as it's warmer than liquid water, warmer than zero, it's going to have a habitable zone. But of course, it's going to be, your moons are going to be tidally locked to the brown dwarf, but then you have that with Jupiter as well. Jim Dika, would we just blindly build it, or would we run experiments, tests, etc., with our info given in the message? I tend to think we wouldn't just blindly build our own device in full without check-in. Well, that's the magic of the bad idea, is that you, as the people who are sending the doomsday machine, is that you wouldn't tell people that it was going to doom them, and in fact, you would hide its true purpose. But there are, even like our current race towards artificial intelligence is a great example of what is potentially a bad idea. That if in the future we can build artificial intelligence where the computers are able to take control of their own development and do research to make better artificial intelligence, then we will get to some place where we will potentially destroy our civilization. And so you can just send what seems like something good, when you think about, say, the Midas touch, right? Midas wanted to be able to, everything he touched would turn to gold, and it turned out to be horrible. He couldn't eat food, turned his daughter to gold. Like, it was a bad idea. And so what we think is a good idea, what even when we test it out in all ways, it seems like it's a good idea, has unintended consequences. And so if the civilization that's sending this to us knows the unintended consequences that will reveal themselves later on. There's this great description of artificial intelligence. I think Elazar Yudkowsky says that it's like a machine that spits out gold until it lights the atmosphere on fire. So imagine if we got the design for a machine that spat out gold until it lit the atmosphere on fire. That is the kind of bad idea that is just too tempting. Even if you knew that it could light your atmosphere on fire, you might still build it because you want the gold until it lights your atmosphere on fire. And a lot of like what we're doing right now with AI, rushing headlong into this, not really thinking about the consequences, not taking it slowly and carefully, feels like we're on that run. Like, it feels like our current dance with artificial intelligence is as if an alien civilization sent us a bad idea and we are just operating it. That if you go and you talk to the people inside the AI companies, many of them say, I would like to slow down. We should pause. This is a bad idea. This is dangerous. And yet they still are rushing forward to do it because they're like, well, better I make the machine that lights the atmosphere on fire than somebody else does first. It's bananas. And yet that's the place where we find ourselves right now. So I think we have a great analogy for this. And this is this idea of an info hazard, that just by knowing a piece of information, you are at risk. And so if some advanced civilization sends us a bad idea, we are doomed. Because we can't help ourselves. We just have to do it because that's how human beings, we're so curious. Drew D2, would a lunar base or space base be more effective for reducing the cost of space exploration? It really just depends on our level of infrastructure. So when you think about a space base, like say we've got a space station that's orbiting around the Earth, and we have spaceships coming and going from the space station, and then the space station has refueling capability, and then people go off into space. And instead of putting it in low Earth orbit, why don't we put it at the Earth Moon L1 Lagrange point, which is this balancing point gravitationally between the Earth and the Moon. And so once you're at that point, then you can head off into the solar system, and you no longer have to escape a lot of the Earth and the Moon's gravity. Or if you go to the L2 point, which is on the far side of the Moon, now you're like right at the very edge of being captured by the Earth and the Moon, and it takes very little propellant for you to then head off into space. So if you put your station down on the surface of the Moon, then if you want to leave the Moon, you're still going to have to fight the Moon's gravity before you head off into space. So that's the downside. But the upside is you have access to solid ground, stuff that you can mine off of the surface of the Moon. You had access to the permanently shadowed craters on the Moon that you can supply water and so on. And when you think about 2001, they ran their mission off of the surface of the Moon, which was pretty cool. And they went off to, was it Europa? Where did they go? Jupiter? Yeah, from there. And so you could imagine one possible future is that we have a base on the Moon that is people are able to then launch off the Moon. You have to pay to get out of the gravity well of the Moon, but it is less than trying to get off the gravity well of the Earth. And the other possibility is that we will have this base out at the L2 Lagrange point, and that will be the waypoint, the gateway, the true gateway to the rest of the solar system. And eventually both will be there. Both will be Both will make a ton of sense, and we will maintain them and use them as ways to get out to the rest of the solar system. That they will be fuel depots, they will be hotels, there will be logistics hubs, communications hubs, and they will provide, and general stores that will provide people what they need before they head off into deep space. Brettle Strander, can you speculate on potential changes to payloads once Starship is constantly launching to low Earth orbit? The 9-meter diameter should be a game changer, right? Yeah, in theory, Starship is a complete and total game changer, an utter disruption to the launch market. That right now, launch costs, even with, say, a Falcon 9 is in the $60 to $90 million range. Falcon Heavy is in the, I don't know, 150-ish million range. Other providers can be more expensive, although there aren't many providers left that will compare. Ariane Space is going to cost you the hundreds of millions. United Launch Alliance doesn't launch very often anymore. Now we've got Blue Origin, but I don't even know what the cost of a Blue Origin launch is. I mean, there've only been 3 so far. Yeah, I should look that up. Anyway, so in theory, I have to keep saying in theory because we haven't seen this happen yet. SpaceX Starship, with its 9-meter fairing, will have one of the lowest launch costs of any provider that's out there. That you will probably pay in the tens of millions of dollars to refuel and refurbish Starship after every launch. I mean, we don't know what the final launch costs are going to be. We've heard Elon Musk say that it's going to be, I don't know, $75 per kilogram or something like that. Like, it's going to be super cheap. Reality, I think, is that it will be affordable, but it'll be as much as SpaceX is able to get away with and still corner the entire launch market. But at the end of the day, this cavernous 18-meter high, 9-meter cross fairing will just be so big and be able to handle so much. You could fit any existing spacecraft in there, multiple spacecraft. And if it's going to be cheaper to launch them on a Starship than any other provider, then everyone's going to flock to these Starships. And in the short term, there aren't enough payloads that, if a single Starship can launch multiple times in a day, but even if it can only launch once a week, then it's going to churn through the entire launch backlog quickly. So, of course, we haven't seen Starship successfully complete its full mission. We've seen the reuse of the booster. We've seen the Starship itself soft land at a designated place without being burned up in the atmosphere. But we haven't seen it return to the launch site, land, then the whole stack get reused. Like, that's the level of reuse that we need to get to for all of these big investments to start to really pay off for Starship. So ideally, in the dream, we enter this new era of completely reusable, fully reusable 2-stage rockets. That would be amazing. The reality is that we probably have more engineering challenges to overcome before this actually happens. But it feels like this is inevitable. This is the future. And just a matter of some company, whether it's happening in the US or whether it's China, which is working on their own versions of this technology as well. One of them is going to come up with it first. Savor Forest. Will AI find alien life first? I mean, astronomers will write machine learning algorithms that will help them find alien life. So think about, for example, trying to comb through all of the radio signals that are coming towards the Earth all the time. That there are signals across all of these different frequencies, across this entire spectrum, all these different sources that could be sending us signals across time. And we've got a lot of places to scan and just mountains and mountains of data to pour through. And that's why, if you remember back in the 2000s, there was SETI at home. You could download chunks of SETI data that had been recorded by these radio telescopes, and then your computer could crunch through them looking for signals. And then if it found anything interesting, report that back to the SETI researchers. And now a lot of that work is done with very large machine learning algorithms, artificial intelligence, but very purpose driven to find these kinds of signals. And that when you think about all the different kinds of technosignatures, the potential technosignatures out there, a lot is going to require going through enormous amounts of data. You're going to want to look through, say, millions of stars all at the same time, looking for any that, for example, are communicating in radio waves, or the ones that are sending laser signals in our direction. Like the star is going to flash because they're firing a high power laser towards us, or that there is a strange shaped space station, like a triangular shaped space station that's passing in front of the star. It's going to be transiting in this way that's very bizarre. Or you're going to be trying to study and analyze the atmospheres of thousands of exoplanets looking for these chemical signatures. And it's too much for human beings to do. So we're absolutely going to rely on artificial intelligence. But then you sort of imagine, could we get to this place where artificial intelligence could actually do the finding for us? Can it come up with algorithms? Can it come up with methodologies? Can it code up solutions to problems where it can actually help find the signals from other life? And almost certainly, it becomes a coding challenge right now, and artificial intelligence, the large language models are very good at coding, and a lot of astronomers are getting a lot of work done using these modern LLMs. So yeah, I think if we do find aliens, then AI will have had a big role to play in us finding them, but not sort of in the way you think. Like it's going to be custom built machine learning algorithms will do most of the heavy lifting of this. Ash D, is gravity the fabric of space-time being sucked into the center of mass of, say, a planet, or the planet itself pushing up? I've heard people say that it's the planet pushing up, which is right. So gravity is a distortion of space-time caused by mass. And so, you've probably seen these sort of 3D looking animations where you have some heavy object and it is sort of like sitting like a billiard ball on a trampoline, and it is pulling down. So it's essentially causing this distortion of space-time. And that causes objects which think they're moving in a straight direction to follow the curvature of space-time. And so that's why things go in orbit around the Earth. The thing that is in orbit thinks that it is going just in a straight line, but the mass of the Earth has curved space-time around it so that what you think is going in a straight line is actually going in this orbit. Fester all day. Can we pick apart sci-fi here? Could astrophage be used as Earth's energy source in lieu of the sun? We could pick apart sci-fi all day long here. Bring it on. So astrophage, this is this bacteria, this microbe that was in Project Hail Mary. I don't want to spoil too much, but this stuff eats the sun and is eating energy coming from the sun. And that in the movie, they're able to use this as a trick. And so the problem with the astrophage is that it has to consume energy from something else. It has to consume energy from the sun. So astrophage is more like a battery than it is an actual power source. And if you read the book, they go into a lot about how they manufacture astrophage on Earth and how much of the world energy output is needed to just produce enough of the astrophage for them to be able to do the Project Hail Mary mission. And so, so it's the same argument for antimatter. People like antimatter is the densest form of energy storage that we know of, that it is It is pure energy equals the mass times the speed of light squared. So if you have a certain amount of mass of matter and antimatter and you put it together, then you get pure gamma radiation photons coming off of that merger between the matter and the antimatter. But antimatter is not a power source. Antimatter is a form of storage, of energy storage. And so if you wanted to send a spacecraft to Alpha Centauri and you wanted to have the spacecraft powered by antimatter, you would have to generate an enormous amount of antimatter. We do produce antimatter here on Earth, but it's used in very specific ways. So, the large particle accelerators like, the Large Hadron Collider, other particle accelerators, they are able to manufacture antimatter, but in the, femtograms, like tiny, tiny amounts of antimatter that they use for their experiments. Hospitals have particle accelerators inside the hospital that they are producing antimatter for, what's the scanner called? PET scanner? I think it's a PET scanner. So they're producing antimatter in the hospital for the PET scanner. So if you ever had a PET scan, that was antimatter. They were generating antimatter in the hospital, and then they're putting it into your body. And when it strikes matter, it explodes, it annihilates and produces energy, and it allows them to positron emissive tomography, allows them to map out the inside of your body. It's amazing. People are like, oh, is antimatter real? Antimatter is being used in your hospital right now. But there was a calculation, I think it was like $62 trillion per gram to produce antimatter, because you got to have this giant facility, enormous amounts of electricity to be able to produce antimatter. Now, we will someday get to a place where we're able to convert matter, or we'll get to some place in the future where we're able to produce antimatter more efficiently. Maybe we'll get down to thousands of dollars a gram, tens of thousands of dollars a gram, which would still be incredible, because that would unlock the exploration of the solar system. We would have rockets. We'd be able to go to other star systems with antimatter. And so same thing with astrophage. It's a method of storing energy, not a source of energy. Unless you had already gotten the ones who had gobbled up energy from the sun and then they came to you. But yeah, you need to produce the energy to feed the astrophage first. Dougal, Nancy Grace Roman telescope is under budget and ahead of schedule. When was the last time a space endeavor did that? I can't think of any other time that a telescope was under budget and ahead of schedule, but I can think of lots of examples of NASA missions where they came in on time and on budget. A classic example of that was the TESS mission, the Transiting Exoplanet Survey Satellite. I think it was a $300 million, I forget the exact budget, but it was, a few $100 million. It was delivered exactly on time and exactly on budget. And NASA is very good at building missions that are on time, on budget. You probably didn't realize how many of the missions that have come out of NASA were on time, on budget, especially the ones that are done within the organization. Like the folks at NASA JPL, they're very good at what they do. Even the folks at Goddard, very good at what they do. It's when you have external contractors, you have legislation from Congress, there's a lot of laws written into it, a lot of back and forth. These things can, and the goals drift and shift. Even like when you think about the space shuttle, when the space shuttle was originally developed, you can go back and look at the original designs of the space shuttle. It was pretty cool. You would have this launch aircraft, and then the space shuttle would be attached onto the top of it, and then they would be lifted vertically, launched like a rocket, and then the carrier aircraft would detach and glide back down and land on Earth, and then the space shuttle would fly to orbit, and then it would return to Earth, glide down. It was a fully reusable two-stage rocket system. But then the military had requirements, Congress put in additional requirements, and they had to change the design to make it a lot less reusable. In the end, only the orbiter part and the solid rocket boosters were reused. They had to throw out the fuel tank every time. But a lot of NASA missions come in on time, on budget. You know, we just have this classic glaring example of the one that didn't, which was James Webb. And then the ones that are in process. I mean, I think the Mars sample return mission, that was one that was already at risk of having budget creep. But a lot of the times, this is a leadership problem, not necessarily a problem from the engineers. Mad Million, if Hawking radiation evaporates black holes, where does the information go? Good question. Like, that is the information paradox, right? That you know, when you sort of think about the classical idea of this, you have a black hole. The black hole is accreting material on the black hole. That the material goes into the black hole and turns into black hole, and then the black hole lives forever as this growing sphere of information. That's fine. Right? Information can go in, it's like whatever happens, it gets mangled and it becomes part of the black hole and it's locked away forever. But Hawking realized that black holes, and now it looks like probably everything, all mass, all matter, will evaporate over time. Neutron stars, black holes, etc. And that as this black hole is evaporating, it's giving off pure energy, and that energy has no connection to the information that went into the black hole in the first place. And that is a no-go. That is a thing you're not allowed to do. And the answer to that question, how can you destroy information inside the black hole, is something that a lot of people have been trying to come up with an answer. But until this point, it's the information paradox. And there's lots of ideas, like maybe one interesting thing is that the surface area of the black hole is sort of your maximum level of entropy, and that the information about what goes into the black hole could be encoded on the surface of the event horizon of the black hole. And then as the black hole evaporates, that information is then re-encoded on the energy as it leaves the black hole. And so it's not lost, it's just changed. Or it might be that it is truly destroyed, and that violates other various physics concepts that are going to have to be resolved. So that's why they call it a paradox. Michael McConnell, are there any plans to build a new radar instrument like they had at Arecibo? Not exactly. So Arecibo was one of the world's largest radio dishes. Was it 300-ish meters across? Now there's a bigger one. The Chinese have the FAST instrument, which is 500 meters across. The 500-meter aperture space telescope, radio telescope. Anyway, but what made Arecibo special was that it had this radar instrument on board. And so they could send a powerful pulse of radio waves from the Arecibo dish at some target. Usually they'd be using this to scan an asteroid. They would then bounce the radio waves off of the asteroid, and then it would be picked up again by the Arecibo Observatory. And it would then be actively scanning the surface. We think about concepts in science fiction, right? You got active scanning versus passive scanning. And so Arecibo could do this active scanning with its radar system. And when Arecibo collapsed, it took this really powerful radar system with it. And there is not one on the FAST telescope. Now, there is one on the Very Large Array, I think. So there are smaller radar systems, and I think there's one was recently installed. And I apologize, I forget which one it was. But so there are smaller radar systems, but nothing as capable as what was on the Arecibo Observatory. And there are no plans right now to build anything that is comparable. And that's the great loss of Arecibo. I mean, yes, the loss of an incredible radio telescope, but the loss of this ability to generate a really powerful radar pulse to be able to map near-Earth asteroids. And it's incredible. When you look at the pictures of the near-Earth asteroids, the mapping done by the Arecibo Observatory, it's absolutely incredible. And they did this for dozens of asteroids as they were doing close flybys of Earth. Oh, was there a fight going on in the chat that I missed? Okay. Lusuk. Lusek. What is the next big space telescope? Well, the next big space telescope is the Nancy Grace Roman Observatory, which is going to be launched probably September 2026. So just a few months away. And Nancy Grace Roman is made of an old reconnaissance space telescope that was provided by the U.S. Reconnaissance Office to NASA. So essentially the space spies, these were telescope mirrors that they had developed that were designed to observe the surface of the Earth, essentially to spy on people and facilities and so on. And the National Reconnaissance Office had these 2 spare mirrors, and they're Hubble class 2.4 meter mirrors. And they reached out to NASA and said, we've got these 2 mirrors. We don't need them anymore. They're not good enough for our purposes. So would you like them for free? Which, when you think about it, that the National Reconnaissance Office had 2 of these mirrors that were as good as the Hubble Space Telescope, and yet they were no longer good enough for their needs. That's kind of scary. But anyway, and so NASA said, yes, please, and started to investigate what they could use these 2 mirrors for. And in the end, they came up with one idea, which was what has turned into the Nancy Grace Roman telescope. So it's a 2.4 meter telescope, but it is configured in a way that gives it a much wider field of view than Hubble. And this is the thing you can just do with telescopes, that you can take a telescope and you can change the optics so that it has either a wider field of view and it is much faster, or it can have a very narrow field of view, very high magnification, but it's slower. And so Hubble, very, very tiny field of view, able to see very high magnification. Nancy Grace Roman, wide angle. And it's an infrared telescope, so similar to Hubble, but Hubble goes infrared, visible, ultraviolet. Nancy Grace Roman is just in the infrared. But then they put state-of-the-art modern instruments on board. Like the Hubble Space Telescope is now 35 years old. So it's had upgrades to most of its science instruments, but it's nothing like what can be developed in 2026. So it's got the ability to take pictures that are bigger than the pixels on any screen that exists, which is awesome. And so Nancy Grace Roman is going to map out the cosmos, trying to help astronomers understand the history of the universe, that it will be able to do these wide angle fields of view, be able to look very deeply into the universe. So think about, say, the Hubble Deep Field. It'll be able to do the kinds of things of the Hubble Deep Field, but much faster, hundreds of times faster than Hubble could. And that then astronomers will be able to look at where the quasars were, what they were doing at different times in the universe, detect supernova, things like that, and understand the influence of dark matter and dark energy on the universe over the eons as early as possible. The other thing that Nancy Grace Roman is equipped with, and this is the thing that I'm even more excited about, is it has a coronagraph. So similar, like James Webb has a coronagraph, and this is a gadget on board James Webb that blocks the light of the star and allows it to reveal the exoplanets that are orbiting around. But it is sort of that's the first iteration of this. And so Nancy Grace Roman has the next version of this, and it will be capable of blocking the light of sun-like stars and revealing Jupiter-sized worlds orbiting around those sun-like stars. And so, we will find and directly observe Jupiter-like planets orbiting around other stars, which will be absolutely incredible. And this is a precursor to the upcoming Habitable Worlds Observatory. So Nancy Grace Roman, at this point, they've done all of the testing, all the integration. The next step is for them to send it off to Cape Canaveral in a month, I think, and then get it all packaged up and ready to go and send it to space in September on a Falcon Heavy. That is the next great space telescope. But there's a bunch of others waiting in the wings as well. So the European Space Agency is building something called Plato, which is going to be a planet hunting telescope similar to TESS, but it has dozens of separate telescopes all arrayed in this sort of matrix on the telescope. So it can look at a bunch of different places all at the same time. There's the aerial telescope, which is also by the European Space Agency, and that is going to be observing exoplanets and studying specifically their atmospheres. So we're going to get information on hundreds of atmospheres of exoplanets, similar to how James Webb does, but at scale, which is going to be great. So there's a lot of space telescopes in the pipeline right now. The Chinese are working on their version of the Hubble Space Telescope. The Chinese, the next generation space telescope, advanced space telescope, CAST. Anyway, the Chinese are working on their version of a space telescope. And this is going to be, let me see. Let me get the actual information. All right, Shuntian. It's a 2-meter primary mirror. CSST, right? Okay. All right, and so the Chinese are working on their space telescope. It's called Shuntian, and it's the Chinese Space Station Survey Telescope. It's a 2-meter mirror, so it's a little bit smaller than the Hubble Space Telescope. And it is going to fly in formation with the Chinese space station and be able to do a lot of similar kinds of observations that Hubble can do. And then when they need to repair it, they'll be able to dock it with the station, and then the astronauts on board the Chinese space station will be able to make the repairs, swap in new instruments, and then it will detach and fly free, because you don't want to be attached to the space station because of all of the vibrations that are going on. So it's a very elegant solution for how to maintain your space station. And that's going to be launching in the end of 2026. So there's a lot of space telescopes coming. Vistotuti, are we capable of launching Voyager-class probes out of our solar system today? For sure. The most recent spacecraft that was sent on an escape trajectory was New Horizons. And New Horizons did a flyby of Jupiter, but it didn't do a flyby of Saturn or Uranus or Neptune, and it is on an escape velocity. It's not going as fast as the Voyagers were, and so it's never going to catch up. It's moving in a different direction for the Voyagers, but it will never catch up in distance to the Voyagers. They are always moving a little bit faster than New Horizons, but still, we have the capability to send an interstellar mission without having this grand alignment of the planets. But that was amazing. When you think about the fact that you could send one mission to do the grand tour, to go past Jupiter, Saturn, Uranus, Neptune, and give us close-up images of all of those for the first time in human history, that you got to see Uranus and Neptune up close. Absolutely amazing. Now we have to send missions to those worlds on their own because they're not lined up, and you can't do gravitational assists to line them up again. And we won't be able to do that again for 150 years or something like that. So we have to do this the hard way. But NASA is working on a mission called the Interstellar mission. And so this would be to send a mission rapidly out into interstellar space, out beyond, say, the Kuiper Belt, out into a region where you're really experiencing the combined solar winds from all of the other stars that are out there. The kinds of observations that the Voyagers are making as they just run out of power with instruments that were never really designed to do this job. What if you could do a much better understanding of how the sun interacts with the rest of the stars in the Milky Way? And so we can see future missions going on escape trajectories, at some point in the coming years. And of course, if you want to go to the solar gravitational lens, that is, 550 astronomical units from the sun. If you want to do that in a human lifetime, you got to go fast, which means you're going to be on an escape trajectory. So any mission sent to the solar gravitational lens will be on escape trajectories. In fact, people are still proposing that we could do missions to do flybys of Oumuamua, Borisov, 3I Atlas even. But, if you took a Falcon Heavy, stripped it down, did a bunch of gravitational assists, you could catch up with Oumuamua in 50 years. So we still have the ability to provide close-up images of even some of the interstellar objects that have come through the solar system if we have the will, which we don't. Johnny Appleseed, what could we learn from launching a probe into a black hole? Well, the problem with a black hole is that nothing can get out of the black hole. No information. The probe is going to be trying to sending home information about going into the black hole, and that information is going to be trapped inside the black hole because you have to go faster than the speed of light to exceed, you have to exceed the speed of light if you want to be able to send a message out of the black hole. And you can't go faster than the speed of light. And so there's no way to communicate information from inside the event horizon to outside. And it might be that there is just never any way that we can understand what's happening inside the event horizon, because it's not just light, gravitational waves, neutrinos, nothing can get out of the black hole. So we would get, but it would still be an absolutely worthwhile mission to send. I mean, we would get a ton of information about the environment around the black hole before the probe crossed the event horizon and the signal stopped. And we would not be able to find out what happened to it after that. It's Skeptic. How far realistically do you think biological humans will ever get from Earth? I would say going to Mars and the asteroid belt is probably places that are feasible and reasonable for us to expect for humans to reach within the next, 100 years or so. Obviously the moon, near Earth asteroids, those are places we're going to go. Mars, that's just a natural. And then maybe going out to some of the asteroids in the asteroid belt. That would be interesting. Trying to make the journey out to Jupiter is really far. It'll take a long time. You're looking at 3+ years each way to go out to Jupiter. That's very hard on the human body. And so unless our technology is really, really good, or we've developed propulsion systems like in the Expanse, it's going to be a while before human beings in our soft, fleshy bodies are going to try to get that far away from Earth. We'll send the robots, right? The reason we want to go to those places to understand them scientifically, we send the robots. But who knows what the future holds for humanity? That if we continue to grow, we continue to develop our resources, continue our exploration, and time just keeps making us more advanced as we develop better and better technology. Centuries from now, we could be across the entire solar system and on our way to other star systems. Best Bear, are you excited for the vast future of larger scale vehicles assembled on orbit? Yeah, I've mentioned this several times that on-orbit assembly is really the next great phase in building stuff in space. And obviously there's the International Space Station, which was built from many different launches that assembled all together in space to create this giant space station. Like no one spacecraft could have launched that. But you can imagine, say, an inflatable space station packed into a Starship could put a pretty close amount of livable volume into orbit in one launch. So there's always something to be said for just sending single launches. And maybe we just make the rockets bigger and bigger. I know Elon Musk said, originally they want Starship to be 9 meters, then maybe they'll be 18 meters across. You imagine an 18-meter wide fairing, what you could pack into a rocket that is capable of launching a couple 100 tons into orbit that has a fairing that's that big. Who knows? But for the real next generation of telescopes, we're reaching the limits of what can be packed into a single spacecraft. And when you look at, say, James Webb, a lot of the expense of James Webb was just the fact that they were having to shave off the weight to be able to handle, the rocket could be able to handle the thing, and have this thing fold in this crazy origami design so that it can unfold in space and be able to serve its function. And really, James Webb at a 6.5 meter primary mirror is the very limit of what can be tucked into a 5 meter fairing. That's what's on the Ariane rocket that launched it. To go bigger, yeah, a bigger fairing would make a huge difference, 9 meters versus, but that gets you maybe a 10 meter primary mirror. If you want to go bigger than that, you probably need to assemble your space telescope. And there was a great paper that I reported on several years ago about this very idea that you launch essentially the bus, the main brains of your space telescope. And then you launch the mirror bits. Maybe you launch them in one launch, or maybe you launch them in separate launches. And then the main telescope bus has robotic arms similar to what they have on the International Space Station. And these will receive the components as they're sent up and then click them into place on board the space telescope as it's building itself. And then you kind of have no limit to how big you can make this telescope. It could be tens of meters across. You just have to design it in advance. And then you can imagine the telescope bus is crawling around the exterior of this growing space telescope, adding and locking in components, more solar panels, more mirror segments, secondary mirrors, new instruments. And you could just keep building and maintaining and growing this space telescope over time as you have more and more resources. And that will be the future. And then you don't have to build the telescope to be able to be unfolded. You just send the raw pieces, and then it's all about, can you align them with precision in space? And we know that you can assemble things in space. We've done it with the International Space Station. The Chinese assembled their space station. So we know that on-orbit assembly is possible, and for the next really big generation of space telescopes, it's going to be inevitable that that's the direction everything moves. Johnny Walker, when will we be able to safely say that Planet 9 doesn't exist if we don't find it? Yeah, I mean, I think there will always be controversy, arguments about this, but if Vera Rubin, which is this new observatory down in Chile, if it completes its 10-year LSST survey of the cosmos and astronomers have not found any evidence of a large planet-sized object moving in the Kuiper Belt, then I think at that point you can pretty safely rule out that it exists. Now, obviously it could be in the northern hemisphere, but Vera Rubin is able to see up into the northern hemisphere, I think by about 20 degrees or so. And then it can see the plane of the ecliptic, which is where all of the planets pretty much are. And then it can see all the way down into the southern hemisphere. And so if this object was out there and it was on an extremely inclined orbit, like something that's like 45 degrees, and it happened to be in the northern hemisphere right now, then Vera Rubin wouldn't be able to spot it. So at the very least, by observing the entire sky at this level of sensitivity, you rule out the kinds of places that this object could be. But I don't think there'll be a lot of people who believe in it 10 years from now if Vera Rubin fails to find it. Church discography. What are you obsessed with? This is the question that I ask my guests. And I like, let me know if you like it. There's a couple of interviewers who have these common questions that they ask their guests. The one that I like is, and the question that I actually ask, like when I interview my patrons, one of the questions that I ask them is like, what's something that I should check out? What's some content creator? What's a book? What's a movie, music, video game? What are you into that I should check out? Because in general, people can recommend something that I've never heard of, that it turns out to be awesome. And a lot of the stuff that I watched today came from recommendations from people. So that's a good question. Like, what's a piece of media? What's something that I should be watching? And I don't know how I came up with that. What are you obsessed with? Just sort of came up in one of the interviews, and I was like, yeah, I'm going to ask everybody this question. So what am I obsessed with? So we do the patrons question show every month, and we start the show me talking about what I'm obsessed with. And so some of the things that I've been obsessed with, I don't know if you sort of see it in the kinds of interviews that I do. So I will do an interview where I'm like, recently I was obsessed with science communication and how, why is there this distrust in expertise? I also became obsessed with recovering and rebuilding my media library, which I've essentially completed. I've rebuilt, going to thrift stores, most of the movies. I'm down to about 40 movies that I still want to pick up, but I've essentially picked up all of the movies. There you go. Dougal is saying, I still recommend you try getting a 3D printer. So I actually interviewed a patron today, and they were into 3D printers, and I was asking them which 3D printer I should get. In fact, I have the tab open on my, they recommended the Bamboo Lab A1 printer. So I'm very tempted to pick up a 3D printer. And I think I opened up this episode talking about how I've been out in the forest and sort of thinking about fires. I'm kind of obsessed with fires right now. I'm really anxious about the El Nino summer that we're about to have. And I know how poorly prepared we are compared to what we could and should be. So that's, like, to be honest, that's what I'm obsessed with right now. There you go. Stormcrow Bamboo A1. Best one ever. There you go. People are saying that I should get CeeLo, I run an A1 nonstop. So that's the one thing that I'm kind of obsessed with, is getting a 3D printer. And there's been a bunch of things that I've wanted to 3D print. I wanted to build a wire management thing for the telescope behind me. So that's cool. And I also want a microscope. So I've been, we've got a lot of really interesting stuff that's in the soil. And I would love to be able to take a microscope and look at what's going on inside my soil. And so there's a couple of patrons who I've talked to, and they have microscopes and I've asked for the recommendations, and I've even asked scientists that I've interviewed for their recommendations on microscopes. So I think right now, 3D printer microscope is what I'm sort of kind of obsessed with right now, but who knows? Ali H. Said, who here has read We Are Bob? I have. And someone said, are we trying to start a baseball team? I think we could. Frank Pace, have you seen Tom Hanks' sci-fi Finch, and what have you thought about it? Was that the one where he's on, like, in a truck? Yeah. Didn't like it. I released my list of my top 100 sci-fi movies about a month back, and I got a bunch of people feedback from, people said, "Oh, you should have put Annihilation on the list." So I'm planning to watch Annihilation to give it another shot. And people said that I should put Oblivion on the list, and I didn't recall loving Oblivion, and I just watched it last night with my wife. I'm trying to give these ones that are on the edge another watch through to see what I think about them. And it was fine. It was better than I recalled, but it didn't make my list. But one that was much better than I remembered was Elysium, which was the Neil Blomkamp. Elysium. Same guy that did District 9. Blomkamp, yeah. And it was good. It was better than, like, there's a lot of problems with it. But as soon as I was like, maybe I'm older and more mature and more level-headed now, and so I'm willing to ignore the awful things that a movie will put in, the bad sci-fi. I'm just willing to just give it, like, no problem, go ahead. And it was fine. Actually, I kind of liked it. And then I'm rewatching Stargate, so we're just at the end of season 6 of Stargate SG-1, just about to start season 7. And it is, of course, still terrific. Such a great show. Vista Shooty saying Oblivion holds up. Still no Minority Report. Yeah, so we rewatched Minority Report, because that was one that I remembered loving, and I still loved it. So Minority Report was terrific, and still has a place on my list. Okay. James Devin, how long can you run lawn sprinklers on top of your house? So yeah, I've got ponds. I've got 2 wells and 3 ponds, although the ponds mostly dry up in the summertime. And so people will actually build these sprinkler systems they can run on their houses. My house is sheathed in metal and has concrete walls and a metal roof. So we have designed it for maximum fire duration to be able to handle being in a fire. But that would be the next level, would be to install those sprinkler systems that you put on your roof, and then you just run them hard during a fire, constantly misting this cloud of water around your house during a fire. And I wouldn't be surprised if we do that. There you go. Zapfan. Aliens turned 40 years old now. Cinema showed a double feature of Aliens this weekend. So I picked up, against my better judgment, where is it? Here. So I bought all my movies, mostly from the thrift store, but I couldn't find Alien or Aliens. And so I picked up the 6-pack. So it is Alien, Aliens, Alien 3, Alien Resurrection, Prometheus, and Alien Covenant. And at some point, when we have the guts, we're going to watch all 6 Alien movies. We just watched the Evil Dead trilogy. They're so great. Evil Dead 2, Army of Darkness. I love those movies. So, yeah. So have you seen Idiocracy? Of course. Oh, is Idiocracy on my list? I didn't even think of if Idiocracy qualifies as sci-fi, but now of course it does. Is it on my list? It is not on my list. Okay, I'm adding it to my list. Yeah, I loved Idiocracy. Okay. Yeah, the documentary. Jack Ray, I bought a Canon 12 by 36 stabilized binoculars after your binoculars answer weeks ago. They are great. Should I get a C-Star next? Wow. I'm glad you are enjoying the recommendation, because that, like, I feel like I should have been, was I not clear that it was an incredibly expensive, like, only buy those image stabilizing binoculars if you have tons and tons of money, because they are very, very expensive. But yeah, they are phenomenal. They're such a great piece of gear. And a 12 by 36, I mean, my big astronomical binoculars are 15 by 75s. And so 12 by 36, roughly the same magnitude. But the fact that they don't shake, you're just looking at an object and it's just perfectly still. That's incredible. You get a C-Star. I mean, C-Stars are great. It is my go-to telescope. Although, now the new one is, but the C-Star is incredible. Just the image quality, the speed, the flexibility of it, really great. Yeah, I recommend C-Star. So yeah, if you can go with the S30, the S30 Pro, or the S50. And I haven't tried the S30 Pro yet. I've just got the S50. But it's so much fun. And I think that, with the binoculars, you're doing visual observing, which is great. You can see planets, you can see the moon, you can see the Milky Way, you can see the Orion Nebula, you can see globular clusters, all kinds of stuff. They're great. And then with the C-Star, you're then taking astrophotos, and the two really go hand in hand. So I think that's a great complement to it. And since you could afford the binoculars, I think you could probably afford the C-Star. Dougal, no Aliens versus Predator. I have Aliens versus Predator. I picked that up. But I haven't watched it yet. And then there's the Aliens versus Predator Requiem, which I haven't even watched, and I will not buy. I keep seeing it at the thrift shop, won't buy it. I refuse. In Minnesota, playing fun games recently. So I've started playing Slay the Spire 2. And like Slay the Spire is like one of the greatest video games ever made. It is so good. And it's set off a whole genre of games. Like, you play Slay the Spire, it's addictive, you'll love it, you'll get obsessed with it, it's so great. And then Slay the Spire 2 is great. And I think leading up to Slay the Spire 2, like, how could they have done anything different than sort of done a better version of Slay the Spire? Because they already kind of developed an entirely new type of game. So yeah, Slay the Spire, that's the one I'm playing. I'm finished my run on Path of Exile right now. I probably won't play Path of Exile through until fall. I just don't have time. So I need games that I can just one-off play for a couple of hours, or like while I'm working out, and then not have to think about it after that. And then come fall, when the bad weather returns, then I'll probably play Path of Exile again, because I really love Path of Exile. It just scratches an itch in my brain. Or Path of Exile 2, whichever one is better. Sean Robertson, maybe I'm being cynical, but how do I know that my telescope is actually taking the picture and not just downloading it? I mean, you can, your telescope can be not attached to the internet and it is still taking pictures. With the C-Star, it can give off its own Wi-Fi, and then you can connect to its Wi-Fi with your phone, and you can be out in the middle of nowhere with no service, and you can be downloading, or you can be taking pictures with your telescope. But you can also do things like put your hand in front of your telescope and it'll stop being able to take pictures. So yeah, it is actually taking pictures of space. Church discography. Hot tub time machine. No. Nope. No, I like I watched it. I didn't love it and probably won't pick it up. But will I? Now I'm wondering if that's like science fiction. It's worth another shot. Let me see. See what's the Rotten Tomatoes. %64%. No. I've decided I'm not going to watch that again. Too much to watch. Oops. Sorry, just okay. I accidentally removed one of your questions. Okay, where are we at? 6:42. Henry Warren, could we resurrect Oppie? So Oppie is Opportunity, NASA's Opportunity rover, and there was the two rovers, Spirit and Opportunity, and Spirit did well, but Opportunity just lasted forever. Was it 10 years, 12 years? I forget exactly how long Opportunity lasted. And in the end, what got it was that it was in the middle of a dust storm, and it was already had dust on its solar panels, and it wasn't able to receive enough power to be able to keep itself warm enough, and it died, which is, it's sad. Could we resurrect it? So the problem now is with Opportunity and with Spirit. Spirit had a problem with its legs. Spirit was like dragging one of its legs behind it when it was still operating. It was so sad. But with Opportunity, once it was no longer able to maintain enough power, then the temperature of its battery system got below freezing and did irreparable damage to the battery system. So if you wanted to get Opportunity rolling again, literally, then you would have to get to Mars, find Opportunity, dismantle it, get to the battery system, swap out with a fresh, properly working battery system, maybe clean off those solar panels, and then you would probably get it to restart and get it operational again. That's, there could be other parts of it, of its electronics were damaged by the extreme cold, but that's the main thing, is the batteries and the solar panels. Fix those and you will probably get Opportunity operational again. And that would be great. I mean, if you remember The Martian, he finds Sojourner. Yeah, I think it was Sojourner, and gets it operational again, is able to use that as a way to communicate back to Earth. Clever. Such a clever, man. Andy Weir, you're so smart. So that is definitely possible, but it would be a great thing to do, to go to Mars, either pick up the spacecraft and put them in museums on Mars, or bring them home to Earth, or build a museum in the actual spot where the different spacecraft are. That would be great. Zappin is Forbidden Planet on the sci-fi list. No. Huh. I watched Forbidden Planet as a kid. I don't recall loving it, but I will give it another try. Page Potter, what's the last thing about space that you changed your mind about? I try to stay pretty flexible and unopinionated about most things in space. So if you told me that dark matter isn't real, I'll be like, okay. Like if there was evidence that the observations for dark matter turned out that it wasn't a particle, that it was just bad observations. If dark energy wasn't real, or if the Big Bang was like any of this kind of stuff. Like if there is evidence to show that this thing is different, then I will change my mind immediately. Are there UFOs? If someone shows me evidence of a UFO, I will change my mind overnight. So almost everything that you could present to me as a scientific question, it's really just the weight of the evidence. And that is the way most people who think about science think that way. It is people who have built up their beliefs without a pillar of evidence, who will then hang on to those beliefs despite evidence that is counter to it. It's very easy for a person who believes in evidence to have their opinion swayed. You just need more evidence. Here's the amount of evidence that for the thing that you used to believe, and here's the amount of evidence for the thing that you now believe. Done. Easy peasy. So I would say the last big thing that I changed my mind about was should human beings live on Mars, right? That when I started, if you'd rolled out Elon Musk's plans for colonizing Mars when I was 25 years old, 30 years old, I would be all in. I attended a Mars Society conference as a journalist, but still, I was pretty excited to go. And now my position is very different. A lot of people have a hard time with it when they hear me say it, because, I think that humanity should definitely go to Mars. People should walk on the surface of Mars as a sort of, that's what's next for space exploration. That we should have a research base on Mars in the same way that we have a research base in Antarctica, in the way that we should have a research base on the moon. But I don't think humanity was meant to live on Mars. Humanity was meant to live on Earth. Earth is the perfect environment for us. And that I also think that human space exploration is inevitable, that we will colonize the solar system, but I don't think Mars is the place we'll do next. I think we'll probably just colonize space itself, space stations, because gravity wells are for suckers. And it's funny to see, like, a lot of the people who were sort of in that same realm as me, having that same sort of personal crisis. I know Cody's lab about a year ago put a video where it's like, I kind of don't think humans should colonize Mars anymore. And Cody is, developing technology in the desert for humans to live on Mars, and was one of the finalists for the Mars One reality show that would send humans to Mars. So I think that is the biggest difference that I've had, where 20 years ago, I was baffled when people thought that we shouldn't live on Mars. And now I'm like, no, I don't think we should live on Mars. So I would say that is the one that I've had the greatest change in my perspective on. And then I would say the other one, which is also sort of grown in me since then, is my perspective on how we're probably alone in the universe. And again, it's just my opinion. This is the thing that I've changed my mind about. I always say I'm a journalist. I don't have opinions. These are the two things that I do have opinions about, because basically they're philosophical questions or economic questions. They're not a scientific question. I mean, are we alone in the universe? This is a scientific question, but we don't have enough information to give a scientific answer, so we have to give more of a philosophical answer. So yeah, I would say those are the two. And if you've been like following my work, I don't know, from the beginning, or like listening to me on Astronomy Cast, if you listen to early episodes of Astronomy Cast, you will hear me wide-eyed excited about the human exploration of Mars. And then you will just hear me become more, I would say more realistic, but you might say more jaded about it over time to where I am today. And it's still a fine line that I have to walk to balance that my raw enthusiasm for space exploration with the reality of how difficult it is and how underinvested humanity has made this so far, that we can't have the gleaming city on Mars if we don't put in the investment, and we do not put in the investment. We haven't done all of the stuff that you would expect a civilization that is obsessed with sending humans into space. We have done the things that a civilization that is just trying to skate on by would put in. But it'd be interesting, I mean, in fact, let's do a poll. Well, I've got a couple of minutes left. So, all right, so did you have the same, does your journey match mine? So let's see here. Do you think we'll have a city on Mars? And so like will people, let's say within 100 years, will we have a research station on Mars? Not will people go to and like Antarctica, right? Like, will we have Antarctica base on Mars within the next 100 years or so? Will we have not a base, but like a city? Like, you go to Mars and you live on Mars and that's your life. You're a Martian now. And you raise your children on Mars and you just do your Mars stuff. And every now and then you interact with the Earthlings, like the Expanse, or even For All Mankind, right? Is that the future of humanity? Or will it be humans live on Earth, and then we have bases, we have research stations around the solar system, and maybe eventually we have that. But that's like beyond 100 years. Like 100 years from now, I don't think we'll have a city on Mars. 200 years from now, probably have a city on Mars, because we'll have cities everywhere. So yeah, so it's really important here. I'm saying research station, like, we all agree there will be a research station, that astronauts will go to and from, maybe even tourists will go to and from Mars, but there won't be Martians who were born and raised on Mars. They live on Mars. They live the Mars life. So there you go. So we got yes, 37%, 38%, and no, 62%. So it's interesting. And so let's do another poll. Did you have a change of heart? So were you like me? Did I do this to you? Now I'm having a crisis of confidence. Were you like, always, city on Mars is a dumb idea? I love space. City on Mars is a dumb idea. Or were you, city on Mars is a great idea. Oh, wait, maybe city on Mars is a dumb idea. So so are you like me? That would be the yes, you had a crisis of confidence. Or no, just from day one, you knew it was a dumb idea. But I wonder how the age correlates into this. Like if you watch the Apollo missions, if you watch the Viking missions, if you were around at that moment, and which is like For All Mankind is really capturing that incitement and enthusiasm for space exploration, then you had a hard fall. As opposed to, I think, the younger people who are just like, nope, this is a dumb idea. Yeah, that's interesting. So 38%, 62% of you didn't have, yeah, 60 didn't have a change of heart. You knew from the beginning. I was the one who had to catch up to you. So there you go. Awesome. That was a lot of fun. Thank you, everyone, for hanging out with me again on this Monday. Thanks in advance to Chad and Anton. We're going to have to edit this nonsense. Thanks to the moderators. I think we've got Arjone and Zapfan. So thanks, guys. Really appreciate it. What's coming up? It's going to be quiet this week. I don't think we have another interview. I think there might be one left in the can. And then I've got to do a bunch of interviews. I'm waiting for Nyack. Where's the Nyaks? I'm worried there isn't a new Nyack. And then what else we got coming up? Oh, we're going to probably record Astronomy Cast tomorrow because Pamela was just getting hunted by tornadoes today. Scary. She had like 3 tornado alerts that came off of her phone that she had to go back to her bunker to wait out. I hope she's okay. I haven't heard from her. All right. Thanks everyone. And we'll see you next week.